Hi everyone, this is Eileen from the Wooldring Lab, and today I'll briefly talk about a paper that looks at how machine learning can guide protein engineering to improve enzyme activity under neutral pH conditions. And enzymes, as we know it, often work best at specific pH values, but industrial and biological settings don't always match those conditions. So this work in this paper explores whether data-driven models can help design enzyme variants that maintain high activity where experiments alone would be expensive and slow. So for this first figure, this figure shows how enzyme activity drops as pH moves away from the optimal alkaline range. The goal of this work is to flatten this curve, specifically trying to improve activity at neutral pH. So for this figure, the authors collected experimental activity data for 27 transaminase variants across 6 different pH conditions and also multiple substrates, that in the end resulted in about 800 labeled data points. Several regression models were tested, and gradient boosting regression trees achieved the best performance with an R-squared around 0.95. In this figure, each row corresponds to a protein variant, and each column to a substrate and pH condition. Together, this was the labeled dataset used to train the machine learning models. In this next figure, you can see predicted versus measured enzyme activity. The tight clustering that is happening along the diagonal shows strong predictive performance, with GBRT achieving an R-squared of about 0.95, which is very promising. And lastly, this figure shows the experimentally measured activity of the top variants selected by the model, and all of them were evaluated at a pH of 7.5. And when we compare this to the starting enzyme, all model-guided variants did show improved activity. This confirms that the machine learning model can successfully guide variant selection under neutral pH conditions. And this work shows how supervised machine learning can act as an efficient screening tool for protein engineering, especially when experimental data is expensive to collect. And lastly, I believe this approach is a good example of where machine learning complements rather than replaces experimental work. Thank you.